I'm going to start a series of videos about solving systems of equations, and so the first video is going to be about actually if they give me the answer, how do I know if that really is an answer to my system of equations? So a system of equations is just when I have more than one equation where we have variables in common, like these are both x's and these are both y's, and so this is a system of equations where my answer would be what x equals and what y equals. So for this example, they tell us that 3, 2 is the solution, and we're basically checking to see if that's right. Well, this 3, 2 is a point, so that's my x and my y. What I'm going to do is I'm going to plug those into both of my equations, and if I get true statements for both, then it is a solution. If either one of them gives me something that's false, then it's not a solution. So if I plug in to the first one, -3 times 3, because that's x, plus 6 times 2, because that's y, equals 10. Well, if I solve this out, -3 times 3 is -9, 6 times 2 is 12. Okay, and then -9 plus 12 gives me 3. And so what I'm asking is this true? Is 3 equal to 10? Well, no, it's not. It's not a true statement. So this is not a solution. Okay, if I had gotten, 10 equals 10, then I'd have to also plug into the other equation. So I would have said 5 times 3 minus 8 times 2 equals -2, and then solve this out. So I get 15, -8 times 2 is -16, and 15 minus 16 is -1. Okay, so that's also not true. So whichever one we had plugged into, basically we would have gotten a statement that was not true, so that tells us this is not a solution. Okay, so if it is a solution, we have to check all of the equations. If it's not a solution and we get that on like the first equation, we can stop there. I just thought I'd show you plugging into both of them, we do get that it's not a solution. But it only takes one of them being wrong to not be a solution. So let's look at this one. Now we have an ordered triple, which is when we have x, y, and z. So that's my x, my y, and my z. And I want to plug in to these three formula or equations to see if these really are solutions. So the first one I'd have 2 plus a -1 plus 3 equals 4. And I want to find out, does that really equal 4? Well, 2 minus 1 is 1. So that gives me 1 plus 3 equals 4. And hopefully we're all like, oh yeah, that's 4 equals 4. So for that one, it checks out that that is a solution. Okay, but we have to go and keep going until we either get all the way through our equations or until we get one that doesn't work. So the second one, 2 minus 2 times y is -1 minus z, which is 3, equals 1. So this -2 times -1 would give me +2. And everything else stays the same. 2 plus 2 is 4, minus 3 is 1. So I get 1 equals 1. That checks out. I have to plug it into my last one, so 2 times 2 minus y, so minus a -1, minus 2 times z equals -1. So 2 times 2 gives me 4. A -1 is really +1. -2 times 3 is -6. So 4 plus 1 is 5 minus 6. Well, that does give me -1 equals -1. That checks out. So the answer to this is that it is a solution to the system of equations. Okay, so that's if they give us an answer, basically. They give us an ordered pair or an ordered triple. They want to know if it's a solution or not, so we plug it in and we see if it really works for that system of equations.